Review number 5. The first thing that you're going to notice is that the review is not very long. There's two reasons for that. The first is the test is only going to cover two topics, which would be voting and apportionment. The next reason is that the review is not going to cover all the stuff that will be on the tests. So at the very beginning of the review, I've got a few bullet points here of things that I'm not actually going to be covering in the review, but you are responsible for on the test. The first, popular vote and electoral vote. It's an incredibly easy topic. There really isn't much to that. Just what I would suggest here is look back at what was done in the activities and especially in the practice work to see how those problems would be laid out. But overall, they're fairly easy questions, and you should be able to go back and look at that information and be completely prepared for that. The second bullet point, supermajorities. Those questions are also pretty easy. Again, go back to the notes, look at the practice work that we've done on it, and that should give you a pretty good idea of what those problems would be. With supermajorities, the information that you are going to need, like the particular numbers for the majorities, whether it's 60% or 70% or whatever that percentage will be, those things will be provided in the problem. So you don't need to worry about those things. Like everything's in there included. Just go look up what the problems are. Apportionments, that's the one that has a lot more stuff going on in it. And the reason that I don't have any examples of apportionments in the review is that they're just really difficult to create good problems for. And I don't want to create something in the review that doesn't reflect well enough to what's going to be on the test. So just like I said, for the others, apportionments, go back and look at the activities and the practice work that we saw. All right, so what we're actually going to be covering in the video are the 5 different methods that we have for voting. Despite the fact that I mentioned a whole bunch of things that we are not going to be covering in the video, this is still going to be the majority of the stuff that we see on the test, because we do have 5 different methods that we've got to go through here. The methods are all going to begin with what we call a preference schedule, which is the table that we see here. This preference schedule does have a total of 4 columns here. Realistically, if we were to do something like this, we would expect to have a lot more columns, even if we didn't have that many people that were involved in the voting. But for simplicity, we're only going to be looking at 4 of them, and it gives you an idea of how things are calculated. All right, so let's talk a little bit about what all this stuff tells us. Hopefully you remember that from beforehand, but just in case, we'll go over it. The first column here indicates that we have 30 people that had voted with, I don't know if we're calling these candidates. These are choices. We'll call them candidates. Because it doesn't actually have to be people necessarily that we're voting for, but I'll go with that and just call them candidates. All right. We had 30 people that chose candidate A as their first choice, candidate B as their second, candidate C as their third, and then candidate D as their fourth, as it's mentioned over here to the side. Okay, so we had 30 people who ranked their candidates all in that order. The second column does not do it in A, B, C, D order. They actually chose C to be their number 1 pick, chose D to be their second pick, chose A to be their third, and then B to be their fourth. 25 people have done that. We have 28 people that put them in this order, and then we also had 17 that put them in that order. So that's what's going on here. Again, you'd probably have a lot more columns because the likelihood that all the people that we had only chose 4 different sequences might not be as realistic, but we're rolling with it here. All right, things that we should figure out at the beginning, because they're going to be important in answering some of the questions as we go forward. How many votes were actually cast? Okay, well, if 30 people chose that order, 25 chose this, 28 and 17 chose this order, you're going to add all those numbers up together, and if you do add them together, you're going to get a nice rounded off number here of 100, which has also been done just for the sake of conveniency. Okay, so make sure you're not mixing up like what we're looking at here as a percentage, like 100% representing all the votes. It's just that it is the same number, that we have 100 voters here. All right, so the next question says, what would be the majority? So the majority is getting more than half. So if we've got 100 votes, 51 would be more than half. So again, I want to make sure that we're not looking at it as just like 51%. It's whatever we do have for the total number of votes that are cast, this should be one greater than half. So if we had 20, this would have to be an 11, something like that. I'll let that be. I think you can figure out any other possible examples. All right, now the most basic way that we could check voting is what we call plurality. Who gets the most votes? Okay, so if you were to really, and all that begins with like your top choice here. These are all your, your second, your third, your fourth, if your top choice is not the one that we roll. But when we talk about plurality, we're only looking at the top choice in each of these. So candidate A got 30 votes here, didn't get any others, right? C got 25, D got 28, and then B got 17. So you're only looking at the top because all those votes are going to go to their top choice. Okay, and then when you do comparison, you see that A's got the most, which is at 30. But did A get did the plurality winner, which is A, also receive a majority? The answer to that would be no. The majority would have been 51, which I think if your plurality winner is also your majority winner, we wouldn't have any argument whether or not that person should be the winner, right? So if somebody got 51 votes and there's 4 people in the race, okay, clearly they're going to be the top choice and the winner. But in this case, that's not, when you really look at it here, A only got 30 votes, which is less than a third of the votes. And A really didn't do that much better than D or C. Not really. I mean, did better than B, but D is like right behind A. So it's a tough sell here to say that our plurality winner should be the winner overall. Okay. So now what we're going to look at are some alternatives that could end up changing who the winner is, or it might confirm that A is still a good pick here. Our next approach to this would be what we call a single runoff. And what we do with this is we identify the top 2 candidates. We look at those 2 and see who does better overall. Okay, so we already know that one of our top candidates, our top one at the beginning here, is A with the 30 votes. The other candidate that would be in our top 2, so our second one would have been D, right? Remember I mentioned D is like right behind A. Now technically C is really not that far behind either, but if we do this method, we're just going to take the top 2, which is A and D. So now what you can do at the table is you can eliminate the bottom 2 candidates, everybody but the top 2. That would be, okay, so that means we're going to eliminate the C and the B. Now what I do in the table is I basically remove the C and the B wherever I can. In these 2 columns, there's not much need to do that because we know that the 30 votes is going to the A and the 20 it's going to the D. But in these 2 columns, if you take out C and B, you're able to easily see I might have said that wrong. If you take out C and B, you're going to be able to easily identify D and A and notice that D is ranked higher than A in this column and A is ranked higher than D in this column. So that means that these 25 votes that would have been going to C are no longer going to go to C. They're also not going to go to B because B's been eliminated, but they're going to go to the next highest ranked one that we kept, which is D. So these 25 votes are going to add to the 28 that D already had, which will bring him to 53 total. A is going to have the 30 plus the additional 17 that are 1 in that last column, which is going to give a total of 47. And now we still have a tight race between the 2 of them, but D comes out as the winner by, it's by 6, so with a little bit more than the majority here. So we get a different winner if we do the single runoff, and it ended up being the one who was right behind A. That doesn't mean that's always going to happen. That's just kind of an interesting observation in this one. All right, so the next 3 that we're going to look at are going to be much more detail oriented. There's more calculations, there's more steps that go into it. Now, in my opinion, the next 2 that we're going to look at, the sequential runoff and the border count, are going to be my favorite ones. And the reason I like those is because if you had to vote and you have a lot of candidates, like our major elections are really only like 2 candidates, except for you can have like independents. But when you're going into a primary, you have a lot of people to vote for, and you might have a few that you really like as favorites, but it's hard to choose between one of them. So these end up giving us a way to acknowledge that you might have some other choices that you really do like in there, and you don't have to completely just go for one person. Okay, so anyhow, I might as well just get to doing the problem, right? All right, sequential runoff. What we do in that is it's like the top two candidate one, but we got to build up to that first. We got to get there first. What we do is not eliminate everybody except the top two, but we eliminate just the lowest person at the beginning, and then all of their votes are going to get reallocated to different choices if they need to be. I mean, they might not even in the first round, and then you're going to get rid of the next lowest voted candidate until you only got one left up at the top. All right, so the table that we have is exactly the same table as the other one. I just wanted to make sure you have multiple copies so that you can mark it up if you want to as you go through this stuff. Okay, at the very beginning, remember each of these are different letters on the top. So it's easy to identify, like A had 30, C had 25, and so on. Now B is the one with the lowest amount, which is 17. So B is going to be the one who gets cut first. So step one, we're going to take out B. Now when I do this one, I do cross out the B everywhere that I see it on the table. Okay, not just this column, because we're going to have to go through this as a series of stages. So I want to really just eliminate even being able to see that letter as I go forward. Okay, now all the votes in the first three columns are going to stay where they are, but the votes in that last column, because B gets eliminated, are now going to move on to C. Okay, now C, who we haven't noticed doing well in the other two versions of this, is now going to gain a lot of votes. C is going to gain 17 votes onto the 25 that he already had. Okay, so that's going to bring C to a total of 42. That's when you add these two together. D still has the 28 and A still has the 30, and that's the end of round one. Okay, now what we do is we look at these numbers, and you're going to want to keep writing these down every step you do. So we're going to take a look at these numbers. You're going to identify the person who has the lowest amount, which is D. So D, remember, was in second place at the beginning. When we did the single runoff, ended up being the winner, but now D is going to get eliminated here in the second round with the sequential runoff. Okay, so D gets eliminated, which means any columns that had D as the top one here, or if D had basically any votes that D had, the 28, like whether that's from one column or multiple columns, those are going to get reallocated to whoever. So what we'll do, we'll go through the table, try not to build just off of these numbers because you might make a mistake there, but go off of the table and just take out all the D's that would be in there and then just reset for everything. All right, so we've only got two people left, right? A and C. So we know there's A and C that are left. A is going to get 30 here. C is going to get 25 here. A is going to get 28 here, and C is going to get 17 here. Okay, so C still has the 25 and the 17, which is the 42, but now A is going to be the 30, plus A picks up the 28 here, which is going to get A to 58, and now A is our winner again. So A was the plurality at the beginning, not a good selling point for winning with only 30 votes, but if you do the sequential runoff, then A ends up picking up enough votes to be the winner. All right, board accounts. Lots and lots of numbers, right? There's a lot of numbers here. However, one of the really good things about the problem is that you don't have to go through and eliminate people and reallocate votes to different places. Like everything is where it needs to be. You just have to get the values of what everything represents, and then you're going to add everything together and get your totals that you can compare. So a bit tedious, but very, very straightforward in how it can be done as well. Okay, the way that it works is if you've got four people that are involved in the race, the top person is going to get 4 points, the next person 3, then 2, then 1. If you had 5 people involved in the race, then it would be 5, 4, 3, 2, 1. If you had 9 people that are in the race, then you would do 9 points, 8 points, 7 points, all the way down to 1. So that's how that part looks. Now, how do these work? Whenever a candidate gets a first place choice, whenever they're a first place choice, they get 4 points for that. Whenever a candidate is a second place choice, or they get 3 points, and then so on down the line. So you're giving, like, whoever you vote for as first will get 4 points for you. Who you choose as second will get 3 points for you, and then down the line, of course. Okay, but what you need to remember here is that at the bottom of the table, there's 30 people that ranked A as their first person. So A is going to be getting 4 points 30 times. Now you can look at this almost just like as a multiplication table here, that you can take the 30 and multiply it by 4, and that means that A, being right here, is going to gain 120 points, 4 points for 30 people. C is going to gain 4 points for 25 people, so 4 times 25 is 100. Let's just pick a random spot in the middle, like right here. B in this column was a third place choice, which is going to give them 2 points for 28 people who voted. So 28 times 2 is 56. So you can literally just multiply across the table and create all the numbers that I'm showing here. However, an even easier way to fill that in is just to count by the numbers at the bottom. Okay, right, 30 times 1 is 30. 30 times 2 is 60. 30 times 3 is 90. So you can actually just start with the number of votes that we had and just write that here in the table, then start to count by it. So 30 plus 30 plus 30 plus 30. 25 plus 25 plus 25 plus 25. And it works all the way across, and that's what I would suggest that you do at the beginning. Again, a little bit tedious, but it's going to organize things a lot. Because when it comes to adding up the total votes, we can do them like this. Just go A, B, C, D. So for A is going to exist in every column. So there's going to be 4 values that I need. Okay, and here's my value. So A is going to get a 120, a 50, an 84, and a 34. 120, 50, 84, 34. Then you add them all up. Then you go to B. You got B as a 90, a 25, a 56, and a 68. And there they all are, and you add them up. That's it. Okay, now, all that should work out pretty fine. When I was kind of going through this, I was looking at, is there a way that we can like have a little bit of a safety net to make sure that we've got the right amount, like totals here, that we didn't make a mistake just going across on that. And a way that we can do that is, you can, it might not make total sense, but I'm just going to tell you what the rule is here. You can add all these numbers together, 4 plus 3 plus 2 plus 1, which is going to be 10. I always remember these as bowling pins, 1, 2, 3, and then 4. Used to bowl when I was a kid. Okay, so that adds up to a total of 10 points. Okay, if you multiply 10 by the total number of people that voted, which is 100, so you got 10 times 100, you're going to get 1,000 total points. So if all of these things add up to 1,000, that's a pretty good safety or checkpoint that you've done this correctly. If it doesn't add up to the product I just described there, then you might have a mistake somewhere in here that you can check. But I'm hoping that, getting this all filled in like that's going to eliminate any real issues anyhow. Okay, so real easily, how do we choose the winner? You look at these numbers. 288 is the biggest of all of these, not by a whole lot, but it is the largest one. So now A is going to be our winner again. So far, it's really looking like A would be the winner, unless you went with the single runoff would have been the one there. Last, what we have is the pairwise comparison, aka round robin. So if you've played sports, this and you know what a round robin is, you can make that as a connection to what we're actually doing here. They're essentially the exact same thing that we've got. What we do here, I mean, the name sort of does help out this way though, versus round robin. And pairwise comparison, you're going to be looking at 2 candidates just to each other, like as if they were the only 2 in the race, and seeing which person is going to get the majority of the votes. Now, since we're only looking at 2 candidates at a time, we're really going back to that number that we had for the majority, which is 51. If a candidate can get over 50 votes, then they're the winner. And I want you to keep that in mind because it eliminates a lot of like extra work that you don't really need to do. Once you reach a threshold of 50, well, plus 50 or 51, right? Then you can stop your calculations. All right, now to do this, what I like to do is create a new table, which seems to have a bunch of dead space in it. But I let it be because it's easier just to have all the dead space in there than to try and modify the whole thing. So basically what I have is all the candidates on one side, all the candidates on the other side, and I'm going to look at each of these boxes as representing, I'll call it a battle, I guess, a battle between them. Okay, now the middle diagonal here that goes across, that wouldn't make any sense because that would be A versus A, B versus B, C versus C, D versus E. So I'm going to take out all of those. And then the bottom ones that I've got here are actually just duplicates of what we see on the other side. Like this is A versus C. Well, this would also be A versus C. It's just called C versus A. Okay, so all that gets eliminated. So it looks like it's a large table, but you end up taking out the diagonal and everything on the bottom side, and that'll leave you with, in this case, we got a total of 6 comparisons to do. Okay, but it does help keep it organized, I think, versus how it may have been shown in the activity. All right, so we don't really care about A versus A. Let's take a look at A versus B and see who does better. Now, it's going to be A. You've got it all filled in for us, but let's see how that works. Okay, what you're going to do is go column by column, and you're going to do like just a look for A and B. What I tend to do is I pick a person that I'm thinking of as the one I'm interested in, and that one is either going to win or it's going to lose. I think just being in that mindset makes it a little bit easier. Yeah, actually, before I start this, let me point out one more thing here. As you go through these, you might start to notice certain values to add together, and I'm going to identify them first. Like if I add 30 and 25, that's 55. If I have any candidate that wins both of these columns, that doesn't matter. Or if they lose both of these, that doesn't matter because this would already be 50, which means that if you win the first or the third one, that's 58. You're still the winner right there. And in fact, these two, those add up to being more than 50. Those are going to be 53. Okay, so when you go through this, if at any point you have a candidate that wins 2 of these, then you don't need to pay attention to the last one. I guess that would be true in all the cases because there's only 2 people at a time. So somebody's got to win 2 of these. Okay, once they win 2 of these, this one doesn't really matter at all. All right, so let's look at A versus B. In the first column, A is going to be the winner. Okay, I'm looking for A mostly. A is a winner. In the second column, A is a winner. A beats B. And as I said before, 30 and 25 already adds up to enough. So it doesn't really matter that A beats B over here and then B beats A over there. Because right there, A's already got the majority. So I'll just go ahead and write in my table in A. Next, I'm going to check A versus C. Okay, A wins here. C wins here. A beats C in the third one. So A has already got 2 of the first 3. That's going to put A at 58. So it doesn't really matter that C is going to win over here. The 58 is already enough for A to be the winner. All right, now I check A versus D. A wins, D wins, D wins. So D actually has 2 of the first 3 columns. The 25 and the 28 will be 53. So it doesn't really matter that A is going to get another 17 to add on to the 30 here. 47 is not going to be enough, so D is the winner. Okay, now we go to B. We got to compare B to somebody. So we did all the A comparisons. All right, B is going to be compared to C. Okay, B beats C. C beats B. B beats C. Right here and right here is enough to get us to 58, and B is the winner. All right, B versus D. B wins. D wins. D wins. Okay, so because D wins in both of those at 53, D will be the winner. Last is going to be C versus D, and that will be our last combination. So C wins, C wins, and I was about to say D wins, but it doesn't matter, right? If C wins here and here, then C is going to be the overall winner with 55 just right there, and then maybe get, then they're going to get even more in that last one there. All right, so here's all the winners, and then what we do is we analyze who has the most. Let's see, A has 2 of them. D has 2 of them, and then B and C each got 1. So what do we actually have here? We have a tie. I was going to write there. We have a tie with A and D. So what do we do? The answer actually is you go and you look at the A versus D column, that one. A versus D, the one combination, that one, and D was the winner in that. So D is going to be the overall winner. That one. That's your tiebreaker. Your tiebreaker is to look at the head-to-head between those two, and D is the winner in that spot.